for practice, right? There's lots of practice problems in there that you can be working on. But just to give you an idea of why on earth we are even introducing negative numbers, I want to talk about what happens when we start dealing with equations that maybe like we did in the past, where we're solving equations that were quadratic and we took the square root of both sides. Now what happens if we're taking the square root of a negative number? We know how to address that. Okay, so the general form, as we talked about with the shuttle game, the general form of a quadratic equation is this: ax squared plus bx plus c equals 0. Again, looking at that, this is a function of x. This is an equation in the variable x. An equation, I see an equal sign. I know it's quadratic because the highest power of x is 2. So since the degree of this is 2, I'm potentially looking for how many values of x? 2. And again, they could be distinct values of x, or they could be repeated values of x. So if I were to give you this quadratic equation and I ask you to solve for x, there's many different ways we can solve some of these problems. In this case, perhaps I would look for a way to factor it. So looking at the left-hand side of the equation, I'm maybe looking for the greatest common factor, which is what? 3x. So if I factor that, I'm going to get 3x on the outside, and what's left over on the inside? X plus 2. Okay, so now I have the product, those two factors set equal to 0. Zero product property says I can set each of these equal to 0. And I'm going to get x equals 0 and x equals -2. Now, in our heart of hearts, we do want to check our solutions that we found algebraically to make sure that neither of them, in this case, is extraneous. Well, but they're not. So our solution set is, write the smallest value first, is that. Now, where we will see this come into play is these are the x values for when our y values are 0. So if I'm looking at the corresponding points, where do these points fall in the Cartesian plane? On the x-axis. So these are in fact your x-intercepts. These are your x-intercepts. They correspond to the solutions, the roots, the zeros of this equation. Make sense? Now, hopefully from Algebra 1, you recall that the graph of a quadratic equation is a what? It's a parabola. And we will see that in this case, the parabola opens up. It creates a mirror image along the axis of symmetry, all of which we will talk about in great detail. If you wanted to find out a little bit more, I could look at the x value in between those two x-intercepts, x equal -1. And if I were to substitute in here -1 for x, what would my y be? If I were to substitute in here x equal -1, what would y be? If I'm looking at y. Mm-hmm. So I'm at the point -1, -3. So I could do a quick little sketch, right? This is just a little foreshadowing of what we're going to do next. But I wanted to make sure that we could see why we needed to introduce these negative numbers. Let's try a next one. Quadratic equation. I want to solve this quadratic equation for the values of x. What am I doing to the left-hand side of this equation? I'm factoring. And can you tell me what my factors are? And give me the factors. So that means x equals what? Mm-hmm. And for kicks, could you tell me what the corresponding x-intercepts are? These are my x values, right?
Yeah.
Right? So that's taking it one step further. Okay, again, using the same properties that we've talked about in the past, let's go ahead and solve the next equation. To do that, perhaps we want to remind ourselves of the definition of the square root of x squared. Remember, this is the absolute value of x. If the input is positive, it equals x. If the input to the absolute value is negative, what do we do to it? Absolute value of x. If the input is negative, what did we do? This is the definition of the absolute value function. We've talked about this. There were two cases. If the input is positive, we keep the x. If the input is negative, we negate it. Remember, how many times have we talked about the definition of the absolute value function? You need to know the definition of the absolute value function. Did we forget that since fall semester? Yeah, okay. This is the absolute value function. We need to be familiar with that. Now, keeping that in mind, if I were to solve this next equation using the square root property, meaning I'm going to end up taking the square root of each side, what would I do first? Add 4 to both sides. I'm doing this using the square root property. On the test, you are going to be asked to solve these equations using specific methods. So if I were to add 4 to both sides, that would give me x squared equals 4. Then what would I do? I would square root each side. So that means x equals what? Plus or minus 2. And this is degree 2, so I did expect those two values of x. Now, let's say you were asked to solve this equation using just factoring. That's the difference of two squares on the left-hand side of the equation. Get the same answer, right? Okay, let's look at the next one. The next one, if I'm being asked to solve this using the square root property, what would I do first? Okay. And then? Okay, so x equals? Okay. These aren't hard, right? What about the next one? What would I do first? Then what? I like it. And then? And what does x equal?
Plus or minus 2/3. No, square root of 2/3.
Okay, now would I leave the answer like that? No, because I know this is plus or minus the square root of 2 over the square root of 3, and I cannot have a radical expression in the denominator, so I have to rationalize the denominator. How am I going to rationalize the denominator? Right? Okay, so then what is really my final answer? Plus or minus? Yes. Those are my two values of x, right? Those are two values of x. Now they get more interesting. This is why we learned imaginary numbers. Look at the next one. What do I do here? Solve for x. What do I do?
You start off by subtracting 4.
Yes. That's going to give me x squared, equals negative 4. I'm okay with that. I'm okay with that. I know what to do next. What do I do? And I'm still okay with that because of what we just learned. So x equals what? square root of negative 4, but x equals plus or minus 2i, right? Because this is the same thing as the square root of 4, square root of negative 1, plus or minus 2i. All right, let's don't stop there. Let's do another one. What do I do in the next one first?
Subtract.
Okay. So that gives me x squared equals negative 12, then.
Square root.
Okay, so x equals what? Excellent. And again, these are quadratic equations, degree 2, so we expect 2 values of x. Oh, okay. So, yes.
Could you do 2i times the square root of 3? What is that?
Yes, but I like to see a coefficient in front of the I, right? The real part of the imaginary part. Real coefficient. So it's algebraic, it's not wrong, because the commutative property of multiplication says that order doesn't matter. That's all multiplication. Okay, looking at the next one, oh, what do you want to do to the left-hand side? Why does it do that? I do. I get this stupid little thing here. Factor the left-hand side and tell me what those two factors are. Ooh. Okay. So what does x equal? Negative 1. What we will see is that this is a double root. So I have only one unique value of x that satisfies this equation. We will see, foreshadowing, that this is going to look like that with respect to the graph of the parabola. Corresponding parabola. Yes, ma'am.
Question. So it says solve quadratic equations by the square root property. Would that be considered the square root?
This is the square root of property. This is factoring.
Would there be a way to do it, like in the square root property?
Normally, you use the square root property when you can isolate an x squared term, and then that would allow you to take the square root of each side. There's a best method to use for different types of quadratic equations.
Right.
Can you? But you're making a mess.
Yeah.
Yes.
So you wouldn't ask on the quiz. Okay.
No. Yes.
So for this problem, it could be like plus or minus.
No, it's not plus or minus. It's only minus.
Substitute, like, see it's not.
No, it's only minus. Only one value of x satisfies this equation. Your solution set contains only one point, one value, rather. Okay. All right, looking at the next one, how am I going to address the left-hand side? Don't be afraid. Yes. What are my two factors? Yes. Okay, so I really only have to solve one of them because it's the same equation. You with me? Then divide both sides by 3. And I get, again, only one value of x that makes this true. We will see again that this is a double root. So we introduce complex numbers, and then now we start solving quadratic equations where if we have to square root a negative number, we know to introduce I. Okay, so that was kind of where we were going with that. So are there any questions on that? No?